I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about some examples of task environments. So what we'll do is we'll explore some examples of task environment, which are the settings in which agents operate to achieve their objectives. Task environments define the challenges, constraints, and dynamics that shape how decisions are made and actions are taken. By examining real world and simulated examples, we will gain a deeper understanding of how these environments influence behavior, problem solving, and performance. Let's move in and discover how task environments impact various systems and scenarios. We'll see some examples. The first example is uh, chess. So here whether it is observable or partially fully observable or partially observable. So for the different types, we are going to discuss. First example is the chess example. So chess is a classic example of fully observable, deterministic, and static environment. Every piece of the board is visible to both players and the rules are predefined, ensuring deterministic outcomes for each move. The game is static as the environment does not change outside the player's actions. Chess operates in a discrete space with a finite possible moves at each turn. It is sequential as each action depends on the preceding moves, and a single agent when training an AI to play against a human or itself. The competitive nature of chess arises from the objective of defeating the opponent. Finally, chess is a known environment. The environment, if you are considering, chess is a known environment because all possible states and outcomes can be calculated, making it an ideal domain for strategic and AI systems. Next, if you are considering the example of poker, the poker presents a partially observable environment since players cannot see each other's cards, introducing uncertainty. It is stochastic due to randomness of the card distribution and dynamic as the state of the game evolves with each round. The game is discrete with the distinct actions like folding, betting, or raising. Poker is sequential because decisions depends on previous actions and it involves multiple agents interacting simultaneously, making it multi-agent. Hope everyone understood. It is competitive as each player seeks to maximize their winning at the expense of others. Moreover, poker is an unknown environment. Here I have not given. The another one more. The example is no environment is known or unknown. So it is an unknown environment since players must infer opponent strategies and intentions based on limited information. Next, solving a Sudoku puzzle. Sudoku is a fully observable, deterministic, and static environment. The entire puzzle is visible to the solver, and the outcome of each action, that is filling in a number, is predictable. The environment is static as it does not change outside the solver's actions. Sudoku operates in a discrete space with a finite set of possible numbers for each cell. It is episodic because it is a episodic, no? Why? Because each decision placing a number does not directly affect subsequent actions. This task is a single agent and there is no interaction with others and is collaborative, focusing on solving the puzzle rather than competing. The environment is also known as all rules and constraints are explicitly defined. The next example, what we are going to see is the stock market trading. The stock market is a partially observable environment where agents cannot access complete information about all market factors. It is known fact. It is stochastic due to the inherent randomness in market fluctuations and dynamic because the environment evolves continuously with the trades, new trades, and external influences. The environment is continuous with the prices and quantities varying on spectrum. Stock trading is sequential as each decision, that is buying or selling, impacts future strategies and outcomes. It involves multiple agents, including traders, brokers, and algorithms, making it multi agent. The market is competitive, with the participants striving to maximize profits and unknown, as future market trends and behavior are unpredictable. Next, puzzle solving, that is jigsaw puzzles. If you are taking these jigsaw puzzles as an example, puzzle solving such as completing a jigsaw is a fully observable, deterministic, and static. The entire puzzle and its pieces are visible, and the outcomes of placing pieces are predictable. The environment is static as it does not changing independently. It operates in a discrete space with finite placement options for each piece. The task is episodic as placing one piece does not affect the placement of others. It is single agent as only one solver is involved and collaborative, focusing on completing the puzzle rather than competing. The environment is known with no hidden factors or randomness. Next, autonomous vehicle navigation example. Autonomous vehicle navigation operates in a partially observable environment as not all road conditions or obstacles are visible at all times. It is stochastic due to the unpredictable elements like weather and traffic. The environment is dynamic, continuously changing as the vehicle moves and interacts with other road users. Navigation takes are continuous, requiring smooth control over acceleration, braking, and steering. The task is sequential as each decision, example, turning or braking, influences subsequent actions. It is single agent, focusing on one vehicle's behavior, and collaborative, aiming to ensure safe coexistence with other road users. The environment is unknown as it involves uncertainties like unseen hazards. So the next example is tic-tac-toe. The tic-tac-toe is a fully observable environment, a deterministic and a static environment. Both players can see the entire game board and the outcomes of each move are predictable. The environment is static as it does not change outside the player's actions. It operates in a discrete space with a limited number of moves. The game is episodic as each action does not directly affect others, and it is single agent when training an AI to play. Tic-tac-toe is competitive as players aim to win against each other, and it is a known environment with all possible states and strategies are calculable. Next example is the robot arm control in manufacturing. So robot arm control is manufacturing is fully observable, deterministic, and dynamic environment. The robot has full visibility of its own workspace at it. Its actions produce predictable outcomes. The environment is dynamic as tasks may involve moving parts or changing conditions. It operates in a continuous no, it is operates in a continuous space requiring precise control over movement. The task is sequential as each action depends on the previous one to complete a process. It is single agent focusing on robots' actions and collaborative as it works to achieve a shared whole, such as assembling products. The environment is known as all parameters are predefined. Next example is very interesting example, self-driving car. A self-driving car operates in a partially observable, deterministic and dynamic environment. The vehicle cannot see all road users or predict all external factors, making the environment partially observable. It is deterministic in its internal decision making, but influenced by stochastic external elements like other drivers' behavior. The environment is dynamic, continuously changing with the traffic and road conditions. Navigation is continuous, requiring smooth adjustment to speed and directions. It is sequential as decisions influences future actions and single agent focusing on the vehicle's behavior. The task is collaborative, aiming for safe coexistence with others and unknown due to the uncertainties like unseen hazards. So the final example is the many more examples are there. So we are going to stop with this. Autonomous drone swarm. Autonomous drone swarms operate in a partially observable, stochastic, and dynamic environment. Not all drones have full visibility of their surroundings, and randomness may arise from external factors like wind or obstacles. The environment is dynamic, continuously evolving as drones move and interact. It operates in a continuous space, requiring precise control over movements. The task is sequential as each drone's action influence the group's behavior. It is multi-agent, involving collaboration among drones to achieve shared goals such as surveillance or delivery. The environment is collaborative, emphasizing teamwork and unknown as external conditions and challenges are unpredictable. Hope all you have enjoyed the examples of this task environment. Thank you. Thank you for joining the discussion of on task environment examples and their diverse attributes, from games like chess and poker to real world applications like self-driving cars and autonomous drones. We have explored how observability, determinism, dynamics, and other factors shape the challenges AI agents face. These examples highlight the versatility, versatility of AI in adapting to different environments, offering valuable insights into designing intelligent systems. Your participation enriched the conversation, and I hope this session deepened your understanding of task environment. Thank you once again.